Hi kids, today we're going to learn about the letter S, which is the symbol for what's called entropy. Here's you about 5 years ago drinking your milk, and this symbol G here is what's called your formation energy. It's named after an American engineer named Willard Gibbs. And it's the sum of all these energies shown here that formed you or brought you into existence. To explain what we're talking about, we're going to look through the book Forces Make Things Move, written by Kimberly Bradley and illustrated, which means drawn, by Paul Meisel. On the cover we see children with lots of energy going around a merry-go-round. Here we see a boy on a skateboard pushing forward with his leg and moving. Moving is the word here. And it means to go from one location or space to another location of space. And to go between two locations of space, a force is required, which is symbolized by these lines. And the boy here is what is called a thing. The TH part of this word comes from the Greek letter theta, which equals the sun. And so a thing is a body that's made by the sun. And forces, which comes from the Greek letter phi, which equals Taz solar drill. Is what makes things move. So here we have a bunch of children in a little lake in the summertime. And the boy here is swinging on the tire tube rope swing. And the force that makes the boy move is called the gravitational force. That means that when the tire is at the high location over here, it is at a higher location with respect to the surface of the earth, and the pull of the earth with respect to the tire makes the boy swing. And we call this force gravity. Over here, we see a boy throwing a ball in the air. And now this energy is called kinetic energy. And this is what's called energy of movement. As we will come to understand, there's different types of energy. Over here we have kids climbing up a wall next to a waterfall. Now the waterfall, or water, which we symbolize by H2O, which is water molecules, this is the same force as the boy on the tire tube swing. That is the water that's at a high location falls towards the earth owing to the gravitational force. Here we see a girl swinging. Forces make things move. Here the force is the gravitational force, which makes her as a thing move back and forth. Now here we are with a very simple diagram. We have 3 rocks which are not moving, or what we call inanimate. We have 3 ants which are moving around, which are like little children. We have 1 mushroom that used to move around, but it's cut, so it stopped moving. We have 1 surface, shown here by the yellow part, which is the surface of the earth. And we have 3 leaves, which used to move when they were growing, but now they're cut, so they don't move anymore. So again, forces move things. Now there's different types of forces that move each of the things shown in this picture here. The rocks don't move because they're at their lowest, what's called gravitational potential. That means there's no force between the rock and the earth to make any movement. The ants and the leaves and the mushrooms, however, move according to what's called the electromagnetic force. Here we see a girl and a boy playing with a car, and there's a cat. Now she, using her hand, forces the car to go forward. This is the force, and the distance through which the car moves is the distance between when she releases the car with her hand and when the car stops over here. So it could be, say, 10 feet on the carpet. Now, when we what's called multiply this force by this distance moved, we get what's called work. And work is another type of energy. So the force of her hand moving the little parrot car forward by about 10 feet on the carpet transforms into work. And that's another type of energy, just like the kinetic energy of this boy throwing the ball in the air, or the gravitational force moving the water over the waterfall. Over here we have a boy pointing out to the girl how to make the little parrot car go faster. The point to note here is that he's telling his sister forces get things moving. So he's saying you have to put more force into the car to get it moving. He also says forces stop things. Let's turn to the next page. Here we see a cat pushing a car. The cat is using its paw, which is a force, to make the car move through a distance, which transforms into work. Now, the important thing you have to remember here is that some forces are very strong. Over here we see what are called light forces, or small forces. That is 3 leaves blowing in the wind. These are falling towards the earth according to a mixture of the gravitational force and the electromagnetic force, which spins the leaves in the air. Some forces are so weak you can't feel them at all. So, for example, this force right here, which is kind of like the wind, is a real simple force, pulling the leaf towards the earth. Over here, we have a stronger force, the hand of the cat pushing the car forward and transforming the heat energy in the mind of the cat into the work of movement of the car. This is a stronger force than the force making the leaf fall. Next we have to learn that no thing starts moving until it is pushed or pulled. The things in question here could be the leaf, could be the cat, it could be the car. So all 3 of these things don't start moving until they are pushed or pulled. So what this means is that just as the car with the bird in it can't move until it is pushed or pulled, so too does a little child not move until it is pushed or pulled. This is what is called the law of inertia. So now that we've got those basic things wrapped up, here's page 7. I'm not going to read through the rest of these things here, but we're going to move back to entropy. So, from what we've learned from the book that Forces Make Things Move, is that over here we have children moving on the merry-go-round. Over here we have the sun, which is warming up the playground, and it releases what's called heat, shown by these lines here, is what we call sunlight. And heat we define by the letter Q. So the heat from the sun, skipping over a lot of details, makes all the children play at the playground and have lots of fun, giving them what's called energy. Now, the way we model this amount of heat is by taking units of these heat, or small quantities, symbol Q of these heats, units coming from the sun to the earth, and we divide these amounts of heat by the temperature of the system where the units of the heat enter the system. So in our playground system here, the temperature is 78 degrees. So when your parents check your iPhone and they tell you that it's 78 degrees outside and you're very excited, that means that we divide every unit of heat Q by this number of degrees in temperature. And when we divide the Q by this temperature, we get what is called the entropy right here. So this is one of the types of energy that go into the formation of you as a child when you came into existence 5 years ago. Now over here we have some new types of energy. This is called H, which is called the enthalpy, and G is called the formation energy. Here are the words. S equals entropy. That is units of heat divided by units of the temperature T is the temperature, which is how warm it is on the playground. H is what's called the enthalpy, and that means heat content. This is a new word, and it has to do with the bonds that you form with your friends. So right here in the middle we have this boy and this girl look like they're close friends. So they have what's called a friendship bond, shown by the two lines here. And we symbolize this by the letter H. And this formation energy can be stored in these friendship bonds, which comes from energy of the sunlight. And this symbol G here is the total energy that formed you. And it's named after Willard Gibbs, and it is called the formation energy. And it is equal to the sum of all your friendship bonds, symbol H, right here, less the difference of what's called the entropic energy. That is the product of the temperature of the playground times the entropy, or units of heat going into the playground divided by the temperature of the playground.